Okay, question 1, part C. Binary numbers are stored in registers. Negative denary numbers can be represented as binary using 2's complement. Complete the binary register for the denary number minus 78. You must show all your working. So here's our register. The first thing we need to do is just check how many bits there are in this register. So our answer has to fill this register. So we got 1, 2, 3, 4, 5, 6, 7, 8. So our answer must be 8-bit. So always read the question to make sure, particularly any sort of conversion question like this, that it might be an extra requirement. Okay, so complete the binary register for the denary number minus 78. So that's our negative denary number. We need to convert that into a negative binary number. So the first part of the process is we need to convert that into its positive binary equivalent. So we just need to work out what 78 is in binary. So to do that, we're going to start off similar to the last question. We're going to have our table. On the right hand side, we're going to put a 1, and then we're going to double those going from right to left. 4, 8, 16. We're going to keep going, and we're going to stop just when we get to a number that's bigger than the number we wish to convert. So we need to get to a number that's bigger than 78. So 16, 32, 64, 128, and I'll stop there. Okay. Now all we need to do is take each number in the table and see if we can take it away from 78. If we can't, we're going to pop a 0 here. Okay, so we can't take 128 away from 78. We can take 64 away from 78. So 78 minus 64, that leaves us with 14. Okay, so let's move on to the next number. We can't take away 32 from 14. We can't take away 16 from 14, but we can take away 8 from 14. So let's go ahead and do that. That leaves us with 6. So we can take 4 away from 6, so we're going to pop a 1 there. That leaves us with 2. And we can take 2 away from 2, so we'll pop a 1 there. That leaves us with 0. We can't take 1 away from 0. So we're going to pop a 0 in there. Okay, now we've done that, we can now go ahead and use the method for converting a binary number into its negative equivalent using 2's complement. And the method is we take our positive binary number here, and to make that a negative binary number, we simply invert or flip the bits, and then we're going to add 1. So first thing we're going to do is going to write down this number, and at this point I need to check we have the right number of bits, because if we don't have the right number of bits, it will affect the answer that we come up with. So we've got 1, 2, 3, 4, 5, 6, 7, 8, and we said we needed 8 bits, so that's okay. If this wasn't 8 bits, I'd simply add the required number of zeros on the left hand side here until we had a number that was the right number of bits. Okay, so to do the conversion, we start off with the positive binary number, flip bits, and then we add 1. So flipping the bits is pretty easy. So that's 1, 0, 1, 1, 0, 0, 0, 1. And now we do a little bit of binary addition, so we're going to add 1 to that there. So yeah, here's our sum. So 1 plus 1 in binary is 2. We can't write 2, we have to write 1, 0, because that's what 2 is in binary. So we're going to put a 0 here, and we're going to carry that 1, because we can only write 1 digit per column underneath. Now we have 0 plus 1 is just 1. And now moving along here, we don't have anything to add to this, so it's going to be the same number. Excuse me, and that is our negative number. We can also tell it's a negative number. We worked out correctly in 2's complement because it starts with a 1, and that indicates, it's not a very good arrow, is it? That indicates that that is a negative number. So we can go ahead and pop the answer into the box here. So we got 1, 0, 1, 1, 0, 0, 1, 0. Now I've done all my workings out in this space here, but you would put your workings here. Again, as I've mentioned before, because of the way I've laid out the slides, I don't have so much space to write in, plus the pen, the way I use it, it writes quite big. Let's look at the answer for that one. So essentially they're going to look for the method, flipping the bits and adding 1, which we've done down here, and they're also going to look for the correct answer as well. So 1 mark for the method, 1 mark for the correct answer. So we've got yeah, we're all good. We're all good for that. Okay, so I'll stop this one and move on to the next question.